Equilibrium of particles. तो સૌથી પહેલા તો એ સમજવું પડે કે equilibrium means what. So whenever the resultant or net force acting on the particle that is zero, then we can say the particle is in equilibrium. એટલે અહીંયા ખાસ ધ્યાન રાખજો, એનું થોડું ફિઝિકલ ઇન્ટરપ્રિટેશન માઇન્ડમાં રાખજો, જે તમને એન્ટ્રન્સ એક્ઝામમાં બહુ જ કામ લાગે. આપણને એવું કહ્યું હોય કે પાર્ટિકલ ઇઝ ઇન ઇક્વિલિબ્રિયમ, તો હવે એનો મીનિંગ એવો થયો કે ધ નેટ ફોર્સ એક્ટિંગ ઓન ધ પાર્ટિકલ ઇઝ ઝીરો, અથવા તો રિઝલ્ટન્ટ ફોર્સ એક્ટિંગ ઓન ધ પાર્ટિકલ ઇઝ ઝીરો. રિઝલ્ટન્ટ મીન્સ or net force means the vector summation of all the forces acting on the particle, and that is zero. હવે જો force zero હોય તો F equal to ma equation પ્રમાણે acceleration પણ zero થાય. એનો મતલબ એ થયો કે stationary object remain stationary અને object moving that move with constant velocity, કારણ કે acceleration 0 આવે. એટલે પાર્ટિકલ ઇક્વિલિબ્રિયમ માં છે એવું કીધું હોય તો તરત જ આપણને ક્લિયર થઈ જાય કે either the particle is steady or it is moving with constant velocity. Now see, suppose two forces are acting on the particle, then in which condition will get equilibrium for the particle? So if two forces are acting on the particle, then vector summation of these two forces, suppose F1 and F2 are acting on the particle, so vector F1 plus vector F2, that should be equal to 0 for equilibrium. So if we take F1 plus F2, that is 0, then we can write vector F1 that is minus vector F2. Clear? So here we can observe this thing. These two are opposite in direction and equal in magnitude. So whenever two forces are acting on any particle, then if these two forces are equal in magnitude but opposite in direction, then definitely the net force will be zero and that particle will be in equilibrium now. Clear? Suppose three forces are acting. See here as shown in this figure, this is the particle at O and forces F1, F2 and F3 are acting on this particular particle. So for equilibrium, the vector summation of all these three forces, F1 plus F2 plus F3, that should be equal to 0. So here take this F2 plus F3 on right hand side. So we can write F1 equal to minus into F2 plus F3. It implies that if we take the summation of F2 and F3, then the resultant vector obtained, that should be in opposite direction of F1 as well as that should be equal in magnitude with F1. Then and then only the particle will be in equilibrium. Clear? So when three forces are acting at that time, if this condition is satisfied, then particle will be in equilibrium. And if particle is in equilibrium, obviously summation of these three forces, that is 0, means if we take the summation of x component of all these three forces, that will be equal to 0. Then summation of y components of all these three will be 0, as well as summation of z components of all these three will be 0. So analytically we can understand this thing by these equations. Graphically here what happens, if three forces are acting on the particle and particle is in equilibrium, means net is 0. So if graphically we represent all these three vectors head tail, head tail, head tail to find out the summation. Then the head of the last one, એટલે કે F3 નું head એ F1 ના tail ઉપર જ સુપરપોઝ થઈ જાય. Means the graphical presentation head tail, head tail, head tail will form a closed loop. Then also we can say the vector summation is 0. તો આને હવે આપણે એક્સટેન્ડ કરી શકીએ. બ્રોડ સેન્સમાં કહેવાય કે if total n number of forces are acting on the particle, then for the equilibrium of particle, the vector summation of all these n forces, vector F1 plus vector F2 up to vector Fn, that should be equal to 0. Clear to all of you?
Yes, sir.
અહીંયા છે ને મેં સિમ્પલી એક આઈડેન્ટિટી આપી છે કે જો અહીંયા એંગલ મેં બતાવ્યા છે ફિગરમાં, જુઓ આલ્ફા, બીટા એન્ડ ગામા. તો વેક્ટર F1 જે છે એનો ઓપોઝિટ એંગલ આલ્ફા છે, વેક્ટર F2 નો ઓપોઝિટ એંગલ બીટા છે, વેક્ટર F3 નો ઓપોઝિટ એંગલ ગામા છે. તો આવી સિચ્યુએશનમાં you will get F1 upon sin alpha, that is equal to F2 upon sin beta, that is equal to F3 upon sin gamma. This identity, that is called Lemmy's rule. આ ખાલી યાદ રાખજો, કોઈક વખત કોઈ MCQ કે પ્રોબ્લેમ સોલ્વિંગ માં કામ લાગે એવું છે. ક્લિયર?